Okay, so in this part for the linear graph, we are emphasizing on the gradient. So like I mentioned in the previous part, okay, I mentioned that in an equation, the gradient is a number that is attached to x. And this gradient, right, allow us to have an idea about how the line will look like. Okay, and it's also a number that measures how steep the line is. Okay, but in this part, we're going to be focusing on calculating the gradient. So if I have a line, how am I supposed to calculate the gradient? But before we calculate the gradient, right, let's have an idea like how I mentioned in the previous section. So if the gradient is a positive gradient, that means it will be like a Superman that flies up. If the gradient is negative, it's downward sloping. And if let's say it's a zero gradient, so do you still recall what kind of line have a zero gradient? So I mentioned previously, a horizontal line is so flat that it has a zero gradient. So zero gradient is like a horizontal line. So a horizontal line has a zero gradient. Okay, so right now we are going to be focusing on how to calculate gradient. If I can calculate gradient and I know the intercept, I can actually tell the name of a line. The name of a line is in the mx plus c. Okay, so there's actually two methods of calculating gradient. Method one will make use of something called rise over run, which I don't usually use because this method will not be used in the upper set. So I will be emphasizing on the second formula for gradient. The second formula makes use of two coordinates to calculate. So I'll be using the second method, and this second method of calculating gradient will still be valid when you go to upper sec, sec 2, sec 3, mainly sec 3. So in sec 3, there will be another topic that use a lot of gradient formula. So you will stick to this gradient formula. So I will not be using the rise over run. Okay, so in order to use the second formula, we need two pair of coordinates. The first pair of coordinates, you call it x1, y1. The second coordinate, you call it x2, y2. Okay, it doesn't matter which coordinate you use. It doesn't matter which one you call it the first coordinate or which one you call it the second coordinate. Okay, so I'll be showing you how do you calculate the gradient on this. Okay, so but before that, right, let's look at the formula first. So if you look at the formula, the top part is the y coordinate. You realize that in the top part, you are subtracting the y coordinate. And in the bottom part, you are subtracting the x coordinate. So it can also be y1 minus y2. Then the bottom part will be x1 minus x2. Okay, no matter what, the top part has to be the subtraction of the y coordinate. The bottom part has to be the subtraction in the x coordinate. And we will be able to calculate the gradient from there. So I will show you using numerical example. So I'll be focusing on using this formula to calculate gradient. And subsequently, we will be able to tell the equation of a curve. Okay, so if you look at example 11a, I got three things to realize. I got three things to calculate. The first one, I got to calculate the gradient. I got to find out where is the y coordinate. And then eventually I got to find out the equation. The equation will be mx plus c. So if you look at 11a, the line is actually flying up. So the line is going up. You are expecting a positive gradient. So you will be expecting a positive gradient. So in that case, later on, if you calculate, you don't get a positive gradient, you need to check where is your careless mistake. Okay, so let's look at the gradient formula first. So the gradient formula is y2 minus y1 over x2 minus x1. Okay, so let me show you how are you going to use the formula. We need two coordinates. Okay, so you must be able to name two coordinates first. Okay, so you must name it correctly. It's always xy coordinate. So you can choose these two coordinates. You can choose these two, or some will be choosing this one. It's your choice. So you just need to choose any two coordinate. Make sure you read the coordinates correctly. So this will be the two coordinates that you have chosen. And I'm going to use these two coordinates to calculate gradient. Okay, so let me show you a trick in calculating the gradient. So in the top part is a subtraction in the y coordinate. Your job is to subtract the y coordinate. So I'm going to help you by doing this. So you subtract this direction. So you do a top part. So you subtract the y coordinate. Then the bottom part, you subtract the x coordinate in the same direction. So in the same direction. You make sure you subtract in the same direction. So that will be how we calculate the gradient. And I end up a positive gradient. So that will be the first part. Okay, and you were expecting positive gradient, right? So, and you calculate out a positive gradient. So you are on the right track. So the first part, I calculate the gradient. So the gradient will be the number beside x later on. But I need to check the y-intercept, the coordinate of y-intercept. So this is the y-intercept. It is flying up at this point. So the y-intercept is actually 0, 1. So now I can tell the equation. The equation will be y equal to mx plus c. The m is half. This will be the number attached to x. And it's cutting at 1. So it will be half x plus 1. So that's how we tell the equation. You get the gradient, you observe the y-intercept, and then we put it together, and that will be the full name of the line. The full name of a line will be half x plus 1. Okay, so again, we're going to try the same thing on the next one. The next one, you find that the line is downward sloping. So you find that the line is downward sloping. So you will be expecting a negative gradient. Okay, so you can choose any point that you like. So make sure you read the coordinates correctly. Some students, right, they make they calculate the gradient wrongly because the coordinate is not even read correctly. Then the top part, you got to subtract the y coordinate. So you are subtracting, so please make sure you subtract correctly. You subtract 0 minus minus 2. So you are subtracting. Okay, then the bottom part, you are subtracting the x coordinate. So subtract in the same direction. So 1 minus 2. So from here, you will get a negative gradient. So it does match the idea that you are expecting, because the line is downward sloping. You are expecting a negative gradient. And the y-intercept is here. The y-intercept is 0, 2. So the line is coming down and cutting through 2. The equation, that means the name of the line. The equation will be y equal to minus 2x. The gradient is attached to x. And then it cuts at 2. So it will be plus 2. So that's how we tell the equation of the line. So we tell the equation by looking at the direction, which is the gradient, and then the y-intercept. Okay, the next one, same thing. Okay, the next one, I need to get 2 points first. So any of the 2 points, you just need to make sure you read the coordinate correctly. So if you read the coordinate wrongly, when you apply the formula, even you apply it correctly, you are not going to get the correct gradient. So you subtract the y coordinate. The bottom part is you subtract the x coordinate. And from here, you get a 5 over minus 4. So the gradient is a negative gradient. So it matches with what we want. And the y-intercept is 0, 5. So it is a line that is flying down. It flies down and it cuts at 5. So it flies down and it cuts at 5. So the gradient is always attached to x. And then it cuts at 5. So the gradient that you calculated, it will be attached to x. So people can see that that's actually the gradient. And then it will cut at 5. Okay, the next one, we are expecting a positive gradient. So get 2 points first. So any 2 points that you like. So write them side by side so that it's easy for you to do a subtraction. Subtract the y coordinate first. Subtract the x coordinate. So the numerator is subtraction of y coordinate. The denominator is the subtraction of the x coordinate. So calculate carefully. So you get a positive gradient. So it's something like within our expectation. We are expecting a positive gradient because it's flying up. And then the intercept, okay, the intercept is a 10. The intercept is 10. So you got to, they never label, but you can count. So from there, you can see that this part is 20. So this part will be a 10. So the y-intercept will be a 0, 10. So it's a line that's flying upwards. It flies upwards and it cuts at 10. So the equation will be the gradient that is attached to x, and it will cut at 10. So that's how we do our equation. So if you want to know the equation, you must first of all get the gradient. Because the gradient will be telling you whether you will be flying up or you'll be flying down. And we need the intercept. Okay, so from the intercept, you know that how it will fly up or how it will fly down. So that will be the generic method that you will find an equation. So if the equation is not a horizontal line, this is the method that we use. We need the intercept, we need the gradient, and then we put it together in the name.